In order to understand what's going on with this problem, it's helpful to understand how to rewrite functions with absolute value symbols as a piecewise function. Let's just focus on the denominator, the absolute value of x minus x squared. The way to write this as a piecewise function is to understand when the expression inside the absolute value symbols is equal to 0. So if I factor that as x times the quantity 1 minus x and try to find out when it equals 0, it equals 0 when x is 0 or when x is 1. And then if you make up a little table like this, you don't have to go into this much detail, but these values where x equals 0 divide the number line into 3 pieces: to the left of 0, between 0 and 1, and to the right of 0. And if you pick a test number in each of those intervals, you can determine what the sign of this expression is, the x times the quantity 1 minus x. To the left of 0, it's negative. Between 0 and 1, that function is positive. Try some test values in each interval just to convince yourself. And when x is greater than 1, this expression is negative. So to rewrite a function as an absolute value function as a piecewise function, you do something like this. Normally we put the rule first, but for emphasis, I said when x is less than 0, the expression inside the absolute value symbol is negative, so we have to take the opposite of that expression in the interval when x is less than 0. Similarly, when x is between 0 and 1, including the 0 and 1, the expression inside the absolute value symbol is non-negative, positive, or equal to 0. So we can just use the expression as it stands, x minus x squared. Finally, when x is greater than 1, we have to use the opposite of the expression inside the absolute value symbol. So when we're evaluating the limit as x approaches 1 from the right, this is the rule that we're using, because we're substituting values for x like 1.0, 1.01, 1.001, just to the right of 0, right of 1, getting closer and closer to 1, but not equal to 1. So if I rewrite the denominator this way, I really am using an expression for the absolute value symbol that will give us a correct value for values to the right of 1. And now I can rewrite it this way. I factored the numerator, removed the parentheses in the denominator, factored the denominator, and see that as x gets close to 1 from the right, but not equal to 1, I can cancel out these x minus 1s. And now I'm ready to try direct substitution. When I put 1 in for x, I get 7 in the numerator, 1 in the denominator, there's the 7. So I was going to show you a Desmos graph, but I decided not to do that.